maintenance technician is to help you maintain the system and to fix it when it breaks down. Every experienced maintenance specialist knows of certain systems. Using the schematic. The most important function of a schematic to you as a maintenance technician is to help you maintain the system and to fix it when it breaks down. Every experienced maintenance specialist knows of certain systems that fail periodically. You must know and understand the system completely before you can analyze a recurring problem and find a solution. The schematic is your main source of information. In fact, if you know the schematic and the system well enough, you can have the equipment operational again quickly. Using the schematic requires knowing how to read it. You must know and understand the system. Engineering designs are not made in heaven, however. Sometimes they involve so many compromises that the results simply will not stand up in the plant, or perhaps the equipment is being used for heavier service than it was designed to give. But before you blame the engineer or the circumstances, make sure that the difficulty is not your problem. Make sure you know how the system should work. If you understand what the operational problem is and how to fix it, and the system still keeps breaking down, then the basic difficulty is most likely in the system or in the way it is applied. Understanding symbols. Pictures and schematics. This unit is intended chiefly to explain schematic symbols, but you will also see pictures and words in the drawings you use. This diagram shows 3 different ways of representing a Y pipe fitting. Which symbol represents a true schematic? That is correct. The correct symbol is C. The first is a drawing that looks like a picture. These drawings are called pictorials. The second is a simpler double-line drawing known as a diagram. The third, a schematic symbol, is even simpler. To the maintenance specialist, they all mean the same thing, a 45-degree Y fitting. What is the advantage of the schematic symbol if you are expected to recognize the picture and the double-line drawing with equal ease? The advantages are simplicity, economy, and the fact that engineers and maintenance workers the world over can recognize it. Notice how much simpler and smaller the schematic symbol is when you compare it to the other 2 drawings. Schematic symbols make it possible to show even a complex system on a small drawing. Schematics show details. This drawing shows schematic symbols for 3 different 45-degree Y fittings. They all resemble the schematic symbol in the previous example. Anyone who knows how to read piping symbols does not need the written descriptions below these symbols. The schematic symbols alone provide all the information. It is difficult to show these differences with pictures or double-line drawings. The schematic symbols shown in this drawing include numbers. The picture and double-line drawing in this first example do not, but you can see that the numbers do not make the difference. Numbers could be added to the picture or to the double-line drawing, but even with numbers they would not be as useful, as easy to draw, or as clear as the schematic symbols. The numbers in these diagrams are the nominal diameters of the pipes. The word nominal comes from the Latin word nomen, meaning name. Thus, the term nominal diameter means name diameter. It is not the exact diameter, but it serves to distinguish one pipe size from another. Symbols that look alike. The symbols shown again in this schematic of 45-degree Y fittings look much alike, yet they represent different fittings. You will find there are many symbols that look alike but have different meanings. Here are 3 examples. Example 1. The symbols drawn here represent 2 relief valves, both remotely operated, but they are different. The difference is shown by the arrow in the center of each valve. One arrow points directly to the line leading out from the valve. The other angles downward. Which symbol represents a normally open valve that would allow pressure to escape? That is correct. When the arrow points directly to the line, it means that the valve is normally open. When it points downward, it means that the valve is normally closed. This may look like a small difference, but it is an important one. Example 2. Here are 4 different symbols for pipelines. They are similar in appearance but different in what they represent. Which symbol represents connected pipelines? That is not correct. The first symbol means that the pipes are connected at the intersection. The other 3 pairs of pipes pass by each other. They are not connected. This chart shows other piping connections and crossovers you may find in piping diagrams. Example 3. Here are 3 different symbols for a T-fitting. The first is a side view. The second shows the outlet turned up. Looking at symbols 1 and 2, can you determine which direction the third turns? Left, right, or down? That is not correct. The third shows the outlet turned down. If you read schematics regularly, you will want to build your own collection of symbols and their meanings. Hundreds of symbols appear in schematics, but not all schematics include legends to explain them. Keeping your own collection will help you identify the less common symbols. Identifying symbols. Tables of symbols that are standard in most industries appear in this and the following lessons. You will receive detailed information about the symbols used to represent electrical, fluid power, and piping components. Recognizing these symbols requires that you match them with their meanings using a legend, or, if the schematic has no legend, a table of symbols. This diagram shows how to match symbols on a schematic with the meaning shown in a legend. The schematic drawing of an electric circuit on the left includes a legend, shown on the right, listing the symbols. Arrows from the legend to the schematic show how some of the symbols match up. Identifying connections. Once you have identified the individual symbols, you must analyze the schematic to see how the parts go together. You already know that various kinds of lines have different meanings in different schematics. Now you must figure out what the lines mean in the schematic you are trying to read. This drawing shows a fluid power schematic with a list of parts and their symbols shown in a legend. You can match the parts shown in the schematic with the list of symbols to identify them. Now look at this first diagram and study the lines used in fluid power schematics. With this help, you can identify the lines shown in the second diagram.
Reading diagrams. Schematics present a great deal of information in a small amount of space. Many problems are created by failure to interpret them carefully. If you always follow a step-by-step approach, you will be on your way toward answering many of the questions that will arise on the job. You will also avoid many possible mistakes when you set out to repair a system. Consider the problem of misfiring in the engine of a truck. The steps are listed in the order you should follow. 1. Identify the system. The title of this schematic tells you it is a schematic of an electric circuit. Even if the title did not tell you, the symbols would. 2. Grasp the nature of the system. What kind of electric circuit is it? Again, the title tells you it is the schematic for an ignition system. But if it did not, the nature of the components would tell you. 3. Figure out how the system should work. The whole system is designed to supply electricity to an engine's spark plugs so that they will fire in the cylinders at the right times. Four, state the problem. Why are you reading the schematic? You can state the problem in your mind. The engine is misfiring. 5. Think why the engine might be misfiring. This schematic shows 5 possible problem areas. The ignition switch might be faulty. One or more spark plugs might be bad. The distributor might not be working right. The coil might not be working right. Or something might be wrong at the breaker points. 6. Study each area of the schematic. This drawing shows 2 parts of the schematic, the spark plugs and the distributor. By studying these areas first, you can find out how the spark plugs fit into the system. 7. Examine the actual circuit. Once you understand the schematic, you can check each part in the truck's ignition system. This method of reading the drawing and relating it to the actual system is an effective way to use a schematic. It takes a little time and patience, plus some thinking, but it will help you figure out what trouble you are looking for and what to do when you find it.
The most important rule to remember about the lines on schematics is that A. They are all drawn according to the same standards. B. They always connect the symbols. C. Similar lines have similar meanings in all schematics. Or D. The lines in a piping diagram are a little thicker than those in other diagrams. That is correct. What shows the direction of flow in a piping diagram? A. Lines. B. The legend. That is correct. Before you can determine the meaning of lines on a schematic, you must know A. The source of the diagram. That is correct. A dashed line on a schematic cannot represent A. Exposed wiring, B. A drain line, C. A vent. That is correct. How many thicknesses of lines appear on most schematics? A. 1, B. 1 or 2, C. 2 or 3, or D. Several. That is not correct. On a schematic diagram, a legend, A, is a brief story about the diagram. B, is a diagram with pictures. That is correct. Which of the following symbols represents a gauge? Click on the correct symbol. That is correct. If the title of a schematic does not specify the type of system it represents, you should A. That is correct. The nominal diameter of a pipe is A. Its name diameter, B. Its precise inside diameter, C. Its precise outside diameter, or D. The ratio of its length to its width. That is not correct. The best way to identify symbols on a schematic is to A. Match them in a table, B. Find out who manufactured the device, C. Memorize. That is correct.